And we're live. So thank you for joining us, Marcin. You are here today to talk about, as the title says, demystifying IoT growth and complexity. So we'll have an intro into AVSystems and your platform, and we'll talk a little bit about, well, the general area of I would say IoT platforms and different ways to think when you're sort of thinking of scaling a product, and what pitfalls there are and such. So maybe we can start by going directly to your introduction screen, and you can tell us a little bit of who you are.
Hello, everybody. Thank you, Frederick, for inviting me. I'm really, excited to be here with you to share, my experience. In general, this would be a talk about, how, in fact, IoT solutions are complex and why they so often fail for us, and what are the problems, things to consider. And this lecture is more about, asking more questions and increasing our awareness about what to ask ourselves, and then giving a definite answer. So please consider it from this way as a just a source of things to consider while building your product. I'd like to briefly introduce myself. For that you guys know me a little bit. So my name is Marcin Nagy. I am currently employed in a company called AVSystem. This is the Polish company that specializes in providing device management solutions. It originally was providing device management solutions for the telco devices. However, in the last couple of years, it is also offering services for IoT, and as well as Wi-Fi value-added services and solutions. And I am responsible for leading the product side in the IoT business unit.
And you said you did your PhD in Aalto University.
Yes. Because we are in the university, so it's also good to say that I have some also academic background. So in the past, I have been studying and living in Finland, in Helsinki area, and I graduated from Aalto University in 2019 with the thesis called Secure and Usable Services in Opportunistic Networks. And opportunistic networks is a form of DTN. DTN stands for delay or disruption tolerant networks. So the kind of networks that assume there is no end-to-end connectivity between the sender and the receiver. So basically, you can assume that there are long latencies in the transmissions, more like, hop by hop, not just store and forward type of routing of the data between the sender and the receiver, but store, carry, and forward, where the middle guys are carrying data in between the next hops on the routing.
So there is some metadata that needs to be carried all the way.
Yes. So basically, it had some. The idea originally started from the concept of the interplanetary internet by Vint Cerf. And then Kevin Fall, in the beginning of the 21st century, started thinking about how to adapt this interplanetary internet into our real-life worlds. There were some ideas with monitoring of reindeers in northern Finland, in monitoring of wildlife animals in Africa, providing broadband internet for rural areas in Southeast Asia and Africa. So in general, you can think that although the general idea was defeated by the prominent presence of the cloud services and abolishment of roaming charges, but some of these concepts have been already integrated into the IoT world, with the latencies, with the lack of dependence on the cloud, different radio communication technologies, and so on.
So this is also
partly related.
Yeah, so heavily linked also to like mesh networking as a concept. So, but WirePass, I mean, that's a Finnish invention, isn't it? That network,
Yes. So it's now a very hot startup from Tampere that they are doing this 5G non-cellular solutions, which is very promising as well.
Yeah, and they also have quite funny promotion videos. So.
Oh yeah, it's very. I think it's very interesting because if you know the story, this is the story. Like one of the co-founders wanted, to honor his mother.
Yeah.
Because of his love, and then it's like that's how he created all the marketing strategy around it, and I think at least it attracts attention.
Yeah, it does. I mean, you can just watch them, and that could be enough. I mean, they are fun. I'll have to put a link on it, and it will be marketing, but I'm not working for them. But I think they are worth checking out.
In this lecture here or discussion, we'll be mentioning lots of companies because I wanted it to make it give us as much of the overview as it's possible, also linking our direct competition. But I think in the end it's all about making informed decisions, and there are no right or wrong decisions. It's all about trade-offs.
Yeah, and isn't that sort of the academic way, that there are no like
yes, try to be as much unbiased as possible, try to talk about the truth and
yeah.
Stay
okay, so thank you very much for your introduction. So and also for those of you that are watching, I prefer that you put any questions or comments in the Discord server. I will be monitoring that at all times. So if there is anything that you want to pick up, then just say. And we might also be able to share the slides afterwards with the students.
Yeah,
I guess.
Of course.
Yeah, okay.
No problem with this.
I should have asked before. But
no, it's like.
Yeah. Okay.
Okay, so let's go next, and I think let's start with this general concept about why we think that IoT is difficult and is complex. And one of the kind of the key insights that we see is that there are proof of concept projects that are being created, but in general the costs of them is way more higher than initially anticipated, and this leads in general to this feeling that the IoT projects are not successful. Some of them are then shut down because of the increasing costs, and in general this kind of promise of the exponential growth of the IoT market and this ubiquitous digitalization of our life is not getting real. And the question is why, and we argue that it's about the complexity, and IoT is complex. If we look at the typical deployment, it involves cloud, so we have cloud services, cloud platforms. We see usually that a single device is sending data to multiple cloud platforms, sometimes using multiple radio technologies, so it's opening multiple connections. There is usually a separate OTA platform for upgrading and making sure that device firmware upgrades is working. There is a network in between the device and the cloud, which is also tricky because there are cellular networks, for example. Usually we have little control over cellular networks. There is LoRa network where the spectrum is unlicensed, so there can be other factors. So you have to take these things into account. Then moving to the left, we have antennas, and then antenna design is a big challenge. There are lots of specialized companies.
They always call that like the black magic, like everything about radio signals and antennas are black magic, or at least from those that don't know how it works.
Well, I think it's a real art how to make a really good antenna. So there are lots of specialized companies that are paid just to create an antenna that is going to work well. So these are all things that need to be considered. And then we are moving just on the device side. And if we are thinking about the device, then device is mostly about the sensors that are attached and some MCU. If we are talking about this device, this is just a device, not necessarily an IoT device, because IoT device needs to have the modem. And then if we think about just the classical device with MCU, there is a flash, there is a RAM, there are peripherals to integrate. These days, security is also becoming a more and more important issue. In fact, we have this CRI, Cyber Resilience Act, that has been approved by the European Commission last year, that is going to be enforced in the beginning of 2025, which puts additional requirements on the vendors or like device makers to make things in a secure way. So basically, trust zone, you need to think how to integrate it. This requires some knowledge on the security side. The APIs are okay-ish. They are basically, it's not so easy, to just start using them.
And they are not standardized as
they are not fully standardized. So there are some follow, some don't follow. It's some are custom. So it's never easy. There have been lots of these efforts coming, from the mobile phone worlds, where there was this TE implemented and there were interfaces. Lots of companies have been investing a lot, like Nokia, Texas Instruments, into standardizing this. And if these concepts are reapplied with one-to-one interfaces, then this things has a chance to be standardized. And then we have like the modem, and modem is like this part that is responsible for sending data from the device to the cloud or to some other servers. And this is again where it's becoming even more tricky, because it's like almost like a separate MCU that is just responsible for modulation, demodulation.
Yeah.
So basically, you either get like this Nordic NRF91 thing where MCU and modem are integrated, and this is great for the developer experience, or you need to plug it in, and then you have to think about coordinating the states, and things again get tricky because you are almost like in this kind of distributed programming sense.
Yeah, and if you also, just to link to what the hardware that the students are using in this course, they use the Raspberry Pi Pico wireless, and then you have the modem or the wireless module. It's actually its own MCU, so it's actually a microcontroller with Wi-Fi that you're only utilizing for the most part just for the connectivity. And then if you want to have LoRaWAN, well, then you have your LoRaWAN modem. We use this M5 stack, for instance, and and it's actually its own microcontroller. So
right. Yeah. And then the challenge here is that sometimes these things are not, again, the APIs for these radio modules, especially on the cellular side, are not well documented. They are kind of working again okay-ish. This means 80% of the time, and sometimes you tweak one thing and things stop to working. So in general, the experience of our embedded team is like, well, it's always tricky with the radio module vendors. And then if you have like the cellular connectivity, there are also SIM cards, and again, the SIM card is another layer of complexity, because there is the need for authentication with the cellular networks. Things can get tricky, and it's one thing, it gets tricky, but if things are not working, then the challenge is that very often there are not so many available developer tools to debug these things. And we have like one of these issues that we have been building a prototype device. It was working fine. And then we just swapped the SIM card, and it shipped it to the customer, and it didn't start. And then, we had to ship it to a telco operator, and it took them, a couple of weeks to identify, because there were not available easily debugging tools for them to understand where the problem lies. And of course, the reason was something silly, but it's like flying blind a little bit with all of this. So, lots in general, that the message that I want to say here is there are lots of, knobs that you need to turn in order to build a reliable, resilient IoT device. And sometimes turning one knob can, have some unseen consequences for the other ones. So it's a tricky process. In the end, we believe, that there is this kind of, multitude of component vendors, cloud connections, and all of this needs to be somehow integrated together in order to improve the general developer experience. The second thing is about the connectivity mechanism. So there are different radio technologies. We are talking about this kind of long-range wireless connectivities like cellular, like LoRa, sometimes even Ethernet, because it's still we have industrial IoT where wired connections are still dominant.
Yeah.
We have this short-range wireless communications like over Bluetooth or even thing like WirePass. You can think about it where this range is not so great, but and then there is this kind of IoT gateways that needs to be implemented, and then the The device is talking to the gateway, and then the gateway is sending data to the cloud. So there is no this kind of, from the security perspective, here there is no this kind of end-to-end transport layer established between the device and the cloud. So this is creating another type of security challenges. And finally, the third type is, again, short-range wireless, but if the device are moving, so sort of asset tracking use cases. And then again, probably you can just assume that the device once is connecting to gateway A, another time to gateway B, and you need to have a way, to handle it and to track this device. So that's another type, of connectivity mechanism that needs to be thought, depending on the use case that you are addressing. So in general, more or less, this is like the categories of challenges that I would like to talk today about. There are many more, but these are something that we know something about, we have experienced. So that's why we would like to focus on this. So first of all, we have this connectivity, and this is especially true for the cellular radio modules, but also we are seeing this sometimes even for the LoRa modules, that there is this poor quality in terms of the API documentation. It gets tricky. So this is something that is really discouraging for people that are developing this. No tooling, especially, like this developing modules, understanding what's going on. There has been this paradigm that I would like to, develop an application using 80 commands to run the module. And lots of developers have been saying, well, I'm stuck because the module is not working as expected. I have opened a support ticket with the module vendor, and then it takes 2 to 3 months, before it's getting addressed. So as a other way, I would like to consider the module to be just the pipeline for me to connect, and I would like to keep the whole application on the MCU side. And the versatile connectivity technology. Then we have the data collection. So this is something that we will be talking a lot. There are multiple ways of approaching this problem, and one of them is that very often people are integrating sensors with just this kind of bare metal approach with the MQTT clients, and trying to make it work. And probably this is the most flexible way to build a device, but again, it's a challenging, and you can run into lots of expected problems with. So maybe there is a thing to think about how to simplify this integration and make your life simpler. Then management. By management, we mostly talk about this OTA, which stands for over-the-air updates of the firmware. And there are very few this kind of out-of-the-box OTA solutions. We, for example, know that like what Arduino is doing, but then at the costs of not giving you any flexibility on how to do it. And then if you want to get some more flexibilities, you can, of course, implement it on your own, or there are some middle ways that we are going to discuss later. And device lifecycle management. Management is one thing, like reconfiguring of the devices, but then there are lifecycle things like bootstrapping, onboarding, decommissioning, all these things that you have to think about the whole lifecycle from the factory until the device is retired, how to transfer ownership. These things probably are not yet so important because we are in the very early phase of the IoT market and nobody thinks about retiring of the devices or changing of the ownership, but these are the questions that will come in a couple of years from now.
Yeah, especially when you have these very long lifetimes of the device's batteries as well. I mean,
so infrastructure is built for years, and lots of things can change,
and they will.
And finally, interoperability, because it's like this clash of IT world and the kind of OT world. In IT, we want to be like Google, like Apple. Let's build everything like in our vertical, everything in home, vendor lock, and it's going to be great. And whereas we are talking with people from electrical engineering background, mechanical engineering background, for them, the norms, standardization, interoperability is something that they see a value in it. So we need to emphasize this aspect, that device A, device B are doing the same thing, but they are sending data in different formats. And it's like a problem, for them aggregating this data, processing this data in the cloud. So there are challenges for this federation. And if I want to send a command to device A and device B, I need to use two different mechanisms, and I'm then creating this kind of the layer on top, gluing this, and well, it's not working perfectly. So ops teams are struggling. So lots of these kind of problems that are caused by lack of focus on interoperability in the early phase.
Yeah. I mean, it's interesting that, I mean, this kind of, if we are actually like, just to give a context, like we're in the 4th week of this IoT course, and we have like designed it so we don't talk too much about all these complexities. We try to make it easy. So that's why we try to introduce these kind of challenges like later in the course, as it is an introductory course. But I agree with everything that you say. I mean, it's really easy to start a project, and that's why we're trying to do that in, like, for instance, in this course. If you have a standardized set of hardware, you're working with tools that behave as they should, but then scaling that to maybe 10,000 devices or 1 million devices over different countries or whatever. It becomes a headache if you don't.
But this is also what makes it so fascinating, and this is really a journey that we are having at the moment. And I think as part of this lecture, I would like to send this message of encouragement, like guys, it's a really fun thing to do, and lots of interesting problems to solve.
Yeah,
you are never getting bored.
No.
So I wanted to now continue about this kind of, the rest of this lecture is about the stories now. So basically of these challenges, and there is a story to tell about how this problem can be addressed. And one of them is this story of the Zephyr Project. And this is one of the ideas about creating this kind of interoperable real-time operating system together with some tooling and additional plugins in addition to just the real-time operating system, as a way to make your embedded code more portable. And the project is already for 7 years. It's been growing really nicely for the last 2 or 3 years. Here I would like to also give credit to 2 companies on the chipset vendor side, the Nordic Semiconductor and NXP, for jumping early onto the project and contributing a lot in terms of the open source. And I think it has done a tremendous job, because lots of this high-level abstract layer that allows you to have the APIs to use it, and the particular adaptation layer for the chipset vendor, it's thanks to them. Now there are more other companies like Silicon Labs, Texas Instruments, and so on. But in general, that they made this lots of impact by jumping early and and betting on this. In addition, I'd like to talk about this other companies like Bruce Wireless, Goliath, and AVSystem that are also part of this project, and they are also making sure that these things, like on the application side, because one thing is the chipset operating system, and then how are you going to build on top of this is what makes the ecosystem so vibrant. The biggest value that Zephyr brings is that it has this support for multiple architectures. So you're writing one piece of code. And then you can, recompile it, for different platforms, and it should work more or less out of the box, depending on the quality of this, adaptation layer. So, to me, this is, addressing these aspects, of interoperability between different, chipset vendors, and also the data collection, because you can integrate sensors easily through the sensor API, and basically you write one layer of sensors, and it should work for different platforms.
Yeah. And you get, like, the idea also is to get like I guess that many students that are in this course might not be like aware of the RTOS. What's an RTOS? You want to give some very short explanation of what an RTOS is?
So RTOS is, stands for real-time operating system, and you can think about it as in general, just a scheduler plus some, library for threads, for handling threads. And this is, altogether what makes, this kind of the core functionality of the operating system. And this is, for example, what FreeRTOS is. And then, you build your application, and then you flash it, and then it's like the real-time operating system that is running this. It's usually a single process, multiple threads, and some, scheduler of the threads, and that's it. Yeah. And then, with going up is like the Linux, embedded Linux. These are, things that are way more rich in terms of the functionalities. Zephyr is something that's why I use this word Zephyr Project, not Zephyr RTOS, because RTOS is just this core part, but Zephyr is also adding lots of these interesting features about, I don't know, logging, native TCP IP stack. All of these things are already included into Zephyr. That makes it more of this kind of something in between the embedded Linux and just this very core scheduler and the thread library.
Yeah. And in terms of, like to put it in the context of what many of the students in this course, they start with MicroPython, and I wouldn't say that you can consider MicroPython an RTOS, but you have you can do threading in MicroPython as well, so you can have separate threads, and you can also write your own scheduler in MicroPython, but you get a lot of these things by default, I would say, in an RTOS. And also, this is not MicroPython or Python. It's you're generally writing C or C++ when you're developing in these kind of platforms.
Okay. Yeah. Do you want to say something?
No.
Okay.
Continue.
Okay. so then I mentioned lots of problems on the connectivity side, and I think there is this company, a hot startup from the United States called Blues Wireless, and basically they are offering their own module that is working kind of worldwide, because they are making sure that all of these roaming agreements are being upheld. And then instead of writing 80 commands to drive this module, they have created a nice wrapper by this kind of API JSON base in order to give you this kind of great developer experience. And they are offering their own hardware. So basically this node card is the module. So basically they make sure that the API is documented, it's working, it's reliable. All of these struggles that we sometimes see by using different modules, which have poor documentation of the API, are gone if you are using their things. So it's just about getting your data to the cloud reliably. And also on the cloud side, they are offering this NodeHub.io cloud service, which is complimentary for free. And from there, you are just routing your data to your platform.
What's the general price point for a developer kit from of this kind?
It's about, I think, 100 something euros.
Yeah.
You get the node card with this 500 megabytes of data included, and there are dev kits. There is Raspberry Pi Raspberry Pi dev kit, and there is something from Adafruit, if I'm correct. Then I think there is different one for EMEA because of these roaming things, and different one for the United States.
Yeah, I need to buy one.
Okay. So this is just a module, and then you need to plug in your microcontroller to it in order to build your application. So it's about solving the connectivity issues. Then there is a story of Goliath, and Goliath is the company that is kind of a competitor to AVSystem, to what we are doing. But the difference between them and us is that they are building their solution on some vendor-specific protocol based on CoAP. But in general, this is the cloud-based platform. Again, they are doing just software, so they are hardware and connectivity agnostic. They don't care about the SIM card, cellular, Wi-Fi, all of these things. They assume somebody takes care of this, and it's very good, for collecting sensor data, doing OTA updates, and the fleet management. And again, they just want to make sure that data land in the cloud. They are not interested in processing of this data. Those processing analytics are done by some third-party platforms and people who are specialists in this. And this is more about this data collection management challenge that those guys are addressing by providing mostly this open source device SDK that accelerates your device development process. Then another story is the story not of the company but of the standard. And this is the story of lightweight machine-to-machine, a standard that we at AVSystem believe a lot in and are investing, and we have built our whole product based on this standard. And sorry, what is this? Basically, when we're talking about Goliath, then they had this CoAP-based protocol, and lightweight machine-to-machine is just the application protocol on top of CoAP that standardizes the messaging semantics between the device and the server. So it provides mechanism for collecting sensor data, standardizing the over-the-air device firmware update process, has efficient encoding in order to optimize bandwidth consumption. You can use JSON or SendML JSON in order, to collect the, multiple time series sensor management.
Yeah.
Oh, sorry. And you can use CBOR as well, like the binary, substitute for JSON in order to make it more efficient, and SendML CBOR as well. Originally designed for CoAP, but then it's been expanded towards MQTT and HTTP. What is interesting in difference from MQTT or CoAP that it has this security by design. So basically aspects of TLS or DTLS are made mandatory. And then there are also these aspects of bootstrapping of a device. So basically the first connection and establishing a trust and management of the life cycle of device credentials and certificates using the protocol called enrollment over secure transport. So basically, it's more than this. It's just this kind of credentials, lifecycle management, and security.
Yeah.
Wireless technology agnostic, and because it's like over MQTT, over CoAP, so anything you can run it over LoRa, you can run it over cellular, over Wi-Fi, over Ethernet, whatever you want. There are even bindings for non-IP data as well. And because of this addition of these security things, then there are partially available device lifecycle management capabilities for provisioning, decommissioning. There is now this capability of ownership transfer. This is not yet. This is not available. This is not standardized.
So generally, like when we talk about like this lightweight machine-to-machine protocol, it's something that you put on like yet another layer on top of more or less whatever you want, as I understand it, and then you get a lot of features like taking the boring part of actually structuring your MQTT data or JSON data or whatever you're sending.
Yes, exactly. That's the value.
Yeah.
And the second is this kind of sensor data description. So and this is something that I mentioned about this interoperability. And there is this IPSO standardization of body that is collaborating with different industries as a way to standardize how a particular sensor should be described in order to boost this kind of interoperability process. And in order for your sensor description to be accepted, then there is this kind of peer review. So basically, I'm submitting this my proposal. This is how we should be. I don't know, humidity meter describing, and there is a committee and experts, and they say, well, yeah, this, and trying to find the loopholes and improve your proposal. And then once accepted, then one goes public. There is this registry under this link of these objects. And basically, I think this is really a nice value, because if I want to build integrate another sensor, I don't need to think it from the box again. I can just go to the registry and say, okay, so this is the model, and somehow trust that somebody did a good job in designing this. And there's this whole description of how particular resources or sensors are being described. So for example, we have this for the location, latitude and longitude is like object number 6. Object number 6, the 0th instance, because there is just one GPS receiver, and this is the resource number 1, which is this. Yesterday, we launched a project called Lightweight Machine-to-Machine Academy as a way, to make it more understandable, because lightweight machine-to-machine is difficult, and we want to make it more easy to understand, more approachable. So we launched the webpage with the project course. It is based, it's like a theory, important, to understand the concept, plus some exercises. So it's being structured around Raspberry Pi Pico W. So I think this is a good match for the summer school. And if you guys are curious to learn more about lightweights, feel free to go to this link, click this link, go to this webpage, and start learning. We are very eager, to get your feedback, what you guys don't understand, what you guys would like to have more, because it's just, the very first iteration. And if you could, contribute and, give us, more questions about what's not understandable, then this would be very valuable feedback for us.
I actually found this seems to be old, but there seems to be Python libraries for this protocol, at least from a small Google search. So I'm just thinking about this. If
there is, because we are also even supporting this kind of developing for Raspberry Pi in Python.
Yeah, okay.
But there's no Raspberry Pi Pico on the standard Raspberry Pi. Okay, so just then the brief story about what we are doing. This is like the final story before we do the live demo, and then we have a discussion. So basically, we have this agent, Anjay, we call it IoT SDK, and this is like the kit that is integrated into the device that allows you to do all of these 5 things. So basically, you are able to send telemetry data to the cloud, do the over-the-air updates, monitor devices and performance remotely, optimize power. Basically, we have this kind of integrations with the radio module. We know that device will go to sleep, so we are know when to shut it down. We know when to expect any sensor things that are going to be measured. So lots of these optimizations that help you save on the battery, and then secure device provisioning through these aspects of security by design of lightweight machine to machine, but also integrations with hardware security modules, integrations with the device provisioning services. And sorry, there is this Coiote counterpart.
Yeah.
Which is like the server side, and this is like the platform where you could execute the OTA update, receive the telemetry data, and push it further to third-party platforms, implement the lifecycle management functionalities, and then get this kind of developer tools that will make prototyping easier of the device.
But we mentioned, like you mentioned also, like over-the-air updates, and like that this was a challenge, and these are also like implemented as a part of the lightweight M2M protocol. So
yes,
yeah.
So lightweight machine to machine takes care of the whole transport part. So basically, how to download the package and how to inform the server about the download. However, in order to make it successful, we need to integrate the bootloader, and then call the bootloader and tell bootloader to update the firmware. So this is another challenge, and this is something that we are supporting as part of these integrations with chipset vendors like Nordic Semiconductor, with ST microboards and so on. And we think this is really critical thing to do it, because everyone needs it, and it's so easy to get it wrong. In the end, this needs to be done securely in order not to break your device.
Yeah, because if this is done wrong, then you might end up with, a large number of devices that are unusable. And
and then you have to go and physically visit them, and these are costs. And so, I think probably this is the most critical feature that is being requested by IoT solution providers.
Yeah. So if you want to go into, like, let's say that you want to develop something and you want to make it like from one prototype, and I like have an idea and I want to have thousands and millions of this device. So what's like the best approach to start? Like what's the first challenge you should address sort of in this journey?
Right. So I think the prototype is usual the kind of the POC phase. This is the most critical one, and we're collaborating with many design houses in order to facilitate this process. And those guys keep saying that again, too many knobs to control, and they would like to build this kind of very simple POC within 2 weeks. So basically 10 working days. And as part of this effort, they would like to spend on this cloud communication aspect not more than 10%. So basically, if you want to be successful, you try to minimize this effort to just 1 working day in order to set all these things up. And this in practice means that make sure that the telemetry data land in the cloud, just in the format that you expect it to be, and have this OTA implemented and tested. Once you have this one, then then they are thinking about, okay, so now let's put this telemetry data into usually InfluxDB, very popular among the developers, very easy to use it. Then visualize it with Grafana because, again, simple and easy to use. And then, you can run this kind of, small scale POC, maybe for 10, maybe for 20 devices, just, to get the concept, get the value. And if you get confidence that this makes sense, then you can think about scaling this towards more like hundreds of devices and more.
Yeah.
So for example, there is one Swedish company, in fact, that I really like as our customers. They are doing this very decent, growth in terms of scalability, and they started, I think, 2.5 years ago with a couple of hundreds devices, and now they are at 140,000. And it's in the beginning it was slow, then 5,000, 10,000, but all the time they were doing this right job about making sure that the prototype makes sense. All of this for them, for example, it was important, this Q mode. So basically the Q mode means that the radio can shut down, data is being collected, is being queued on the device side, and then it's being sent once the device wakes up. And on the same thing for the server. If there were commands to be sent for the server to the device, then they are queued on the server side, and then once the device wake up, then they are being transformed. So to answer your question, I don't think there is one right answer. It's all about
of course.
it's all about doing things, I think, at their own pace and understanding what's the bare minimum set of requirements that you want to achieve, and then just do it and verify it and think about the steps.
Yeah, but we talked a little bit earlier, and I just explained on what like the majority, I would say, of the students in this course are developing. I said that we in some ways we try to simplify things as much as possible, and then you said something interesting that like a lot of these simple projects are really not that simple.
True.
Yeah.
I think things get tricky definitely if you are getting on the cellular network. That's for certain. I think if you are doing over Wi-Fi, then I think it should be reasonably safe, and of course depending on the different verticals that you are addressing, the criticality, the security, all these things start to matter. So I think the Huckster way, like the Huckster IO platform projects, I think that they are quite nice, they are quite simple to do, but are these production ready solutions? Probably not, or maybe not all of them.
No, I would say like the majority of the projects that you can find, like they are like a lot of things that you can find tutorials and like it's fun to do, but it's very much do it yourself. And I think that, like the value of at least this kind of presentation is that, well, there is a lot of complexity when you go into like doing something which will be a product later on, or because you might have a new feature or a new security update or whatever. You might want to exchange one of the sensors at your MCU because you don't, well, maybe it's not manufactured anymore, and then the next batch and you need to send out new firmware updates or what. So that complexity, you really don't handle that complexity when you're building a do-it-yourself project. But still, it's the same bits and pieces that needs to be connected in some way. So
exactly. So I was thinking we could do the short demo.
Yeah, let's do it. A short demo. Live demos are always super fun. So
okay. So basically, can you see my screen?
Yes.
Yeah.
We do.
So there are slight problems with this because I'm at the conference right now and took the wrong cable. So it's my colleague that is facilitating this in the office that has set up this Nordic NRF91 dev kit.
Yeah.
But in general, you log into the platform, and this is kind of your inventory of the devices. The devices can be like all of these projects that you have are being, aggregated into some, we call it, organizations. Each organization have different sub-projects and so on. Here I am just, in my internal IoT project with just 3 devices that we have. There are functional, okay, there is no stated up, but we have this kind of operational center where we see about, things that, where we can monitor devices that are currently doing, and if there are any alerts being raised. So for example, there has been this kind of resolved alert for my device. This device stopped working. So basically there is an alert, failed to update registration, which means that went offline. As an ops engineer, your responsibility here is just, in this view, to make sure that all the devices are fully operable, or the number of alerts that has been raised is, as little as possible, close to 0. And then you have all of these things like, you can acknowledge the alert and write some notes about, because it's about like also collaborating, leaving your notes for your colleagues in order, to make sure, that you are able to solve the problems. We have these functionalities of grouping, and this is still the old view that we are, rewriting. Integrations, basically we provide integrations with different platforms from Microsoft Azure, from AWS. We are going to launch more integrations in the coming weeks. Location services, basically NRF Cloud, we have this, very fruitful collaboration with Nordic. So if you are building a product that requires using assisted GPS or predicted GPS or Wi-Fi based or cellular based location services, this is a really good feature, because guys from Nordic Semiconductor are creating a very robust, database that helps you speed up time to find your location for the device. And this is like, the speed up is about, then saving battery lifetime.
And then we're talking about databases of different locations, sort of
yes.
based on MAC addresses for Wi-Fi hotspots near, or that kind of thing, or?
Yes, exactly, exactly. And also there are these kind of ways, for us to build tests. For example, I will change this domain to the root, in order, to show this kind of tests for the devices as a way, to make sure that they are working. So this is more like a developer tool. Waiting for it to load.
It's a live demo, so it needs to be some hiccup, otherwise it's not.
Yeah. Okay. Well, maybe we can get back to this, but I wanted to show you guys this thing. Basically, how we are doing the over-the-air update for this particular device. So this is Nordic NRF91 device. This is the kind of the dashboard of the device with the location. This is somewhere in the city of Krakow in our office. This kind of, cellular network, it's been registered when it was last seen. Configuration parameters, currently we are using the no security mode, but you can, change it towards adding, different pre-shared key for DTLS or certificate based. For the sake of, simplicity, we are just using no-sec. And then this data model. This is where this is like, I have been talking about these objects, and basically this is how these lightweight machine-to-machine objects are being, implemented, and what kind of, the values that they are being, shown here. So for example, this kind of location services, the latitude, the longitude, when it was measured, some statistics about, the connectivity, cellular connectivity objects, the state, like the PSM timer, active timer, lots of things, lots of objects that are being implemented on the device side and also on the sensor side. So we have like the temperature measurements, temperature in the room where the device is located, some measurements related to accelerometer, and so on. Basically, with this one, we are able, to send commands to the device. For example, we can say that there are these measurements, maximum measured is 39, minimum is 9. This is the range, and you can just send, okay. So from now on, let's reset this. and we are going, to schedule the execution of this thing in order, to reset our measurements. And let's see. Yeah, so basically, previously it was 9, now it's 3. $42. So
Yeah.
the ranges are changed. And then I wanted, to demonstrate you the concept of this Overtheair update for this particular board. So basically here you could see, the versions, the kind of the dashboard where you see, the process of the history. We had lots of errors today because wrong firmware. We have been aborting some of these things just before this call. So, there are also errors and wrong updates that can happen. And, it's also really vital to make sure that your device still stays connected if there's some error that are appearing during the OTA update process. So if you want to, start it, you click this update firmware update, and then there are two things. Basic firmware. Basic firmware is about flashing the whole, flash the whole device, or multi-component, where you are dividing your flash into multiple components. A component can be an application, can be bootloader, can be a modem, and so on. And this way, we are just updating a particular component. And this is, a way, to save, amount of data that is being sent, reduce the time for the execution of the FOTA process, and so on. So basically here, I'll take application. We have this application file to do it, and maybe we can do the bootloader here. The boot, save it. Then we need to set up, the parameters. The parameters is that it has to be CoAP, not CoAP S, because we are using this no sec. Everything else should be fine. We are clicking next. Just verify that everything is fine, and then we just schedule update. And now we can be, just waiting and seeing, tracking the progress. Update, transferring package. The state of the device has been changed to upgrading. And it should take around, I think, 3 minutes. Here we see this is in progress, and so we can come back to this tab. Or maybe we can just keep discussing, and the tab is waiting here. And I think about in 2.5 minutes from now, we should see some more changes.
And if this update were to fail, it would roll back automatically, or
yes. Yeah. Because this is the value of integrating, our agent with the bootloader. In this case, we are using MCU boot, and then MCU boot is making sure, that the device is able to boot correctly. And if the boot fails, then it's doing the rollback to the previous version. So there is no easy way that you can brick your device.
Yeah.
If you are following this.
Yeah, and then now you said that this is an NRF device. So this same workflow, could this be on what kind of devices do you actually support?
So basically, Nordic is our favorite because of the really nice developer experience. But we also have this kind of similar things built for STM32 type of devices. Here we are talking about L4, L5 line, and U5 series. And Espressif 32 using this ESP IDF. And at the moment, we are focusing mostly on this. We have a demo for Raspberry Pi as well, and Raspberry Pi Pico. It's available on our IoT developer zone as well.
Yeah.
And probably, in the coming months, we are going to focus a little bit more on the embedded Linux, since we see lots of potential there for doing this. So more of this, integrations with the particular platforms will be made available.
Yeah, so when you talk about embedded Linux, then it could be also like a Raspberry Pi and not a Pico, for instance. So anything that could run with an ARM processor, a CPU.
Yes, more or less. And I think ESP32 is not ARM because it's 10 silica and now RISC-V. So basically, MCU or like microprocessor architecture is not so important. It's more about integration of the bootloader, which is critical.
So in theory, it could be also a server. It doesn't need to be. It could be any kind of computing platform.
But because then you can think about it right now. Okay, it's finished. Yeah, it's finished. Success. 2 minutes 51 seconds. And then the upgrading also the icon stop. This is about the firmware, but then you can think about if you have a more powerful device running, for example, embedded Linux, then you have embedded Linux and multiple applications. And then you can think about updating the software. And this is probably another thing that we are going to add. And then you have this kind of almost like the Synaptic package manager for PC, but for the Linux-based devices. And then if you make another step forward, you can think about all of this, K3S, all this kind of containerized deployments on the small IoT devices. And then you can think about, managing containers as another step.
Because I think, if you look at, if you go a little one step further above, like the small microcontrollers, if you go to Raspberry Pi, we have this Balena system that sort of does the same thing, but it runs. Is it Yocto Linux that it runs as the base, or?
Yes, I think it's the base.
And then you update the containers, which is quite neat way of doing it. So you're going sort of that track as well.
Because we think in the end, for example, if you want to have a compelling offer for example, thread-based solutions. So this thread, like this technology for the wireless mesh networks, you have to address the end devices for thread, which are this kind of small NRF52 microcontrollers, but also there are thread border routers. And as an ops engineer that is responsible for making sure that all the updates are applied, you want to do it in one place.
I got a question from the server here. What's the most interesting application in IoT that you know of?
Okay. There have been a lot. I think I don't have anyone that is particularly my favorite. I am a person that is concerned about ecology, so I see a lot of really fascinating use cases about some companies that, for example, are trying to solve the problem of scarce water resources and how to measure this. And I'm cheering a lot because I think it's a really important social problem to solve. Again, the market is hot. There are lots of solutions, but I like those. I like those ideas about for example, in the city of Baltimore, I read recently about 60% of water is being wasted due to some faulty infrastructure, lots of leaks and so on. So, for example, if there are solutions that use acoustic engineering in order to detect leaks, I think it's a very right purpose to do it. There are stories about helping farming in Africa, and I think this is also very interesting because lots of people are suffering from hunger in Africa, and if these things can help, that this is really great. So I would say I'm mostly interested in these industrial use cases, not so much in home appliances, because in home, well, it's cool, it's nice, but maybe it's not bringing so much value to the society.
No, I can agree on that. So it's fun, it's cool, and I mean it's fun, absolutely. But maybe having that button that hits your car automatically, or you get a ping when the mail arrives. Well, maybe it doesn't transform the society in any meaningful way. So.
So I think all of these use cases about utilities and helping manage our natural resources better are I would say very, very interesting, and I cheer up to all those people that try to solve these problems.
Yeah. And I think, I mean, you mentioned 60% of the water in
Baltimore, United
Baltimore,
States.
yeah. And I
And
think
I don't know if this is verified number. At least this was some some article in the journal that I have been reading that and
yeah. But I think that I think this was in the Ny Teknik. It's a Swedish newspaper, engineering newspaper. If I do remember, I might be wrong now, but I think like it was 30% or such. That I think this was in the West Coast. If it was in Gothenburg, and don't take me by the numbers literally now. I might, but we have sort of the same problem also in Sweden with infrastructure, that there is a lot of water leakage in the system. So just by fixing all that, like, and being able to measure all things, I mean, that gives a great value to society.
yeah.
So,
and I think in the beginning it's maybe not about solving this problem, but just about measuring, because when you measure,
yeah.
you know at least how bad it is, and bringing awareness. And so, for example, I come from Krakow, southern Poland, and we have lots of problems with the air quality due to using too much of this kind of coal heatings, poor quality coals.
Yeah.
And there has been a company called Early that has been established in the city a couple of years ago, and they are not solving this problem. They are just measuring and publishing this data. And I think this has done a lot of good in terms of raising awareness of people, of the citizens, that this is really a problem, and starting discussion. And I think this is already a great contribution.
Yeah. And there is this project, it's called Open Air Quality Monitoring. Isn't it a German project that sort of you put up your own air quality meter in the city, and then now I'm taking this off top of my head. But yeah, I'll see if I can find the links later on. But there are these projects that do like this city science approach of measuring data. We got some more questions. Well, you can probably read them in the Discord server as yourself. But like one question is about how probable it is that the technology will be used to create a society that monitors everything we do, a surveillance society.
Oh yeah, I think that's a tough question, and
yeah,
I don't know. It might be just a fluke. It may go this way or the other way. I think, for example, these days we are talking about artificial intelligence and what ChatGPT is doing, and this kind of revolution. Will this be put to the good use, or will this be put to the evil use? I don't know. I think it has the potential to do a lot of good things. But are we as a society will be acting responsibly? We will see. And I cannot say how likely it is. I think in generally in European Union, if we see the trends in the recent years with GDPR, with this cyber resilient acts, focus on privacy, that a lot of good things have happened, and people started talking about privacy, and the privacy laws has been enforced. So in terms of the privacy and this surveillance dystopia, I'm quite optimistic. This is unlikely going to happen, but you never know. And of course, there are different geographical, different countries, different legal systems. We see the similar movements in the United States, the state of California, the state of New York. There are already discussions on the federal level about imposing something similar to GDPR. So at least I have this feeling that in the Western world, these things about privacy are being considered, and this makes me an optimist.
Yeah, we need to be optimists. So, yeah, you got a question also about certificates and how they are used in. Yeah, maybe you can read the question yourself.
Right. You mentioned using certificates. Are they used in order to exchange keys with asymmetric encryption to start the TLS with symmetric encryption? Basically, if you are using the certificates normally, for example, from your PC, then the browser, for example, let's take an example of the browser. Your identity is not being validated by the server. The browser is authenticating the server in order to make sure, that it is actually, if it wants to talk to, I don't know, bbcworld.com, it is actually bbcworld.com and not somebody impersonating bbcworld.com. But the client side is not being authenticated. In the IoT world, the situation is slightly different because you are interacting, with the real device, not with just, in the closed authenticated system, not with just a random guy that wants to, get and read some news on the internet. So the identity of the device needs to be authenticated by the server by the server side. So basically, the device needs to send the certificate saying, this is my identity and this is my name, and this name has been, verified and signed by the trusted PKI, and you can trust that I am who I am. I'm not impersonating another device. So this is, and in TLS, this is called MTLS or MDTLS, mutual TLS, and this is like an extended flow of authentication for TLS in order, to establish a symmetric encryption for the further communication.
Yeah. How often, like, we're talking about encryption and such, and like, you could either do this in software. You could put your certificate on the device, and or you could have a small a crypto chip, or what's how does the area look like? Like, if we look at IoT devices, what's the general?
It's growing. I think the awareness is growing.
Yeah.
There are lots of use cases that, especially in the very beginning, they are ignoring this situation, saying, okay, well, I'm just whatever, doing some thermometer measurements.
Yeah.
I get hacked. Well, okay, who cares?
Yeah.
But then things are improving. We are getting lots of questions about how are you managing the credentials on your device? Are you able to provide the integration with the secure elements? So first of all, I think that technology is maturing, because I think 5 years ago it was even impossible to think about having secure elements on MCU-like devices. So technology is there. I think now it's about time to build awareness, especially in this kind of utilities domain where we are actively working a lot. They consider this to be part of this critical infrastructure, so they say it must be secure. So secure elements are a must.
Yeah, and one more question I thought about now. I think we have more questions in the Discord server, but when we're talking about this standardization of actually, because I think that is quite a challenge, even if you start your own like hobby project, is that I have my sensor data. It might be a temperature reading. You might start by just printing it out in the terminal, and then next step might be that, send it somewhere, and then, well, I need to save it in a database. You mentioned InfluxDB. We also a lot of people are using that. It's really convenient, but you need to choose first, what you should call your sensor and what kind of value it is, and what is it, the temperature, etc. How this lightweight M2M protocol, like how easy is it to integrate that with, like, say, InfluxDB, for instance? Is there a plugin, or is it a standardized way of doing that?
Yeah. So basically, we are building a plugin at the moment for us, and we're going to make it part of the platform. But our embedded guys have been creating this kind of Python-based clients that is able to transform this data into the InfluxDB. So I wouldn't call it very difficult.
So if you're let's say that you're using LoRaWAN, this protocol would probably be on the network server side, because the LoRaWAN protocol wouldn't be an idea of putting that protocol in that space, or
there is a lot of overlap between this lightweight machine-to-machine objects and LoRa, because LoRa do not have this kind of standardized description of the sensors, but it used to have the format called Cayenne LPP.
Yeah, I'm aware of that. Yeah,
that was at some point looking that it might become a de facto standard for this, and Cayenne LPP was taking inspiration from this IMSO standardization objects that is standing behind lightweight machine to machine. So there is some overlap. LoRa is a little less standardized. We'll see how these things are going to evolve. We know that there are already some signals in the LoRa community that some standardization, not necessarily on the sensor side, but more on like on this management side, might be needed in order, to maintain the current growth of the market. In the beginning, everyone was so excited, they were just building. Now it's time, to operate these things. So of course, this creates this needs for management.
Yeah. And then just thinking about payload decoders. I mean, if you go into the AVSystem and you buy like a LoRaWAN sensor from different vendors, everyone has their own way of they have their own decoder and they format the data in their own way. And they often provide a decoder, but sometimes you have to write your own decoder. So
I think I've been to this TinyML summit in March in California, and there have been lots of this discussion about like ways to standardize sensors, because they say we are all engineers, we understand it, we understand the data sheets, but to have one common format would be nice. At least this would simplify our job. So I think there is this growing awareness that some standardization is useful, and because some people say, well, of course it's true that standardization is kind of tidying you, but on the other hand, it's also sometimes useful. So it's all about finding the right balances.
We're over 1 hour and even 11 minutes, but maybe we can take a last question. Do you think that solutions that address for the home can be developed to address larger climate environmental issues, or do you see these two as separate areas?
Well, I think that there are some links into this, because if you think about smart home and for example optimizing the energy processes in smart homes, I think that there is a value, right? And then we see the smart grids being implemented, and smart grids are owned by homes. Is smart grid a home appliance, or is it more like an industrial appliance? It's something in between, right? Smart home, smart office, maybe there are similar concepts. In offices, lots of things can be made into more smart way in order to better use of resources. So I think there is some overlap, and in general, the better we have this collaboration between these things, the better for everybody.
Okay. This was a really interesting discussion, so thank you very much. I'm so happy that you took your time, and you're at the moment in Prague for the Zephyr
Developer
conference.
Summit. Yeah.
So that you took your time to actually join in. That was wonderful.
It was a real pleasure, and thanks to everybody who attended it. And I also like to stay on the Discord channel if there will be more questions. Sometimes questions pop up later. I'll be happy to look later and answer them. So thanks a lot.
And we also probably also say that, well, you are, like you said, that this platform that you demonstrated, like the first 10 devices were like you could open your own account, no cost. Yes. And it also supported by the Pico platform, and you had your own beta version of the course.
Yes. So for this, I maybe put a link, because we have this. All of this is described in our developer zone, how to bootstrap yourself with the Raspberry Pi Pico, and then how to use the platform. I also would like to to encourage you guys to maybe get into the academy project if you are keen to learn more about things, and if you find this interesting, then this would be really cool. And I also think the feedback will be very valuable. So feel free to reach out and tell us if this makes sense.
Okay. We'll put out the links, and I say thank you very much for attending, and bye for now.